Across these lessons, our retriever has always done the same thing. Find the chunks most similar to the query. For local questions, where the answer sits in a passage or two, that works beautifully. But ask this: how is Maria connected to Project Atlas? Maria founded Acme, and Acme runs Atlas. But that link is split across two different documents. No single chunk mentions both, and the bridging fact isn't even similar to your question, so similarity search simply misses the connection. This is multi-hop reasoning, and FlatRag is blind to it. Now ask a bigger question: what are the main themes across all 10,000 documents? The top 5 chunks can't possibly summarize a whole corpus. The root cause is the same in both cases. Vector RAG retrieves content, but it throws away the connections between facts. GraphRag fixes this by making those connections first class. Instead of a bag of independent chunks, it builds a knowledge graph. The entities become nodes, and the relationships between them become the edges. Each fact is a tiny triple. Maria founded Acme. Acme runs Atlas. Strung together, thousands of these triples form a web of knowledge. Now the connection between Maria and Atlas isn't lost between two documents. It's an explicit path you can walk along. That one change reshapes both halves of the pipeline: how we build the index and how we search it. Building that graph happens offline in a few stages. It starts, as always, by chunking your documents. But then, instead of only embedding each chunk, an LLM reads it and extracts the entities and the relationships between them as structured triples. Those triples are assembled into one big graph. Every entity a node, every relationship an edge. A crucial step here is entity resolution, recognizing that Acme, Acme Corp, and the company all refer to the same node, and merging them so the graph stays connected instead of fragmenting. And every node and edge remembers which source chunks it came from, so any answer can be traced right back to the original text. With the graph built, GraphRag does something clever to handle those big global questions. It runs community detection using an algorithm like Leiden, which finds clusters of densely connected entities, groups that link to each other far more than to the rest of the graph. Each community is essentially a theme, and it's hierarchical. Smaller communities nest inside larger ones, giving you the corpus at every level of zoom. Then an LLM writes a summary for each community, a community report, and these are generated once ahead of time. Those pre-written summaries are the real secret to answering global questions, without ever having to reread the entire dataset. At query time, GraphRag picks one of two strategies, depending on the question. Local search handles specific entity-centered questions. It finds the entities from your query inside the graph, then traverses outward to their neighbors, gathering the connected facts and their source chunks. That is exactly how is Maria connected to Atlas gets answered, by walking the path from Maria to Acme to Atlas. The multi-hop problem solved. Global search handles broad, thematic questions instead. It takes those community summaries, has the model partially answer from each one, and then combines them into a single comprehensive response. Two retrieval modes aimed squarely at the two gaps we started with: local search for connecting the dots and global search for seeing the whole picture. Where does this shine in the real world? Anywhere the relationships are the point. In medicine, linking drugs, genes, and diseases across thousands of papers. In finance and law, mapping who is connected to whom for compliance and fraud detection. And in the enterprise, asking what themes run through every single support ticket. But it isn't free. Running an LLM over every chunk to extract entities and then summarizing every community makes indexing far more expensive than plain embeddings. So here's the rule of thumb: reach for GraphRag when connections and big-picture synthesis are what matter, and stick with VectorRag when your answers live in a single passage. Because in the end, regular RAG finds the right passages. GraphRag understands how they connect.